So number 7 is a follow-up question to number 6. It asks if 1 molar NaOH were added to 100 milliliters of water instead of the phosphate buffer in number 6, what would the pH have been? All right, so for this, we're asked for pH, but we're not dealing with a buffer system. So if we're not dealing with a buffer system, we don't need to use Henderson-Hasselbalch. All right, so instead, we're going to be relying on the definitions of pH here. All right, so the definition of pH is the negative log of our proton concentration, right? Other things we know about pH are that pH plus pOH equals 14. Well, from this problem, what can we calculate? Well, we have a volume of sodium hydroxide, the concentration of sodium hydroxide, and the final volume. Well, that allows us to calculate the final concentration of sodium hydroxide using our dilution formula. C1V1 equals C2V2. All right, so we'll have the left side be our concentrated side. So we have 1 milliliter, the concentration is 1 molar, volume is 1 milliliter. All right, and I'm after what is our final concentration here. Our final volume is going to be the 100 plus the 1 milliliter we're adding, so 101 milliliters. All right. When we end up doing this, we'll get our C2 is equal to the same number that we derived in the previous problem, 9.9 times 10 to the minus 3 molar. All right, now, so this is the concentration of our sodium hydroxide, or just hydroxide, since we assume strong bases fully dissociate in water. All right, well, what does this allow us to calculate? Well, pOH is equal to the negative log of our hydroxide concentration, right? Well, we just determined the hydroxide concentration, so let's go ahead and calculate a pOH. So negative log of 9.9 times 10 to the negative third. What do we get here? All right, what we get is 2.00 for the pOH. All right, now the question is asking for pH. Now, at this point, this is a very easy problem for us to do because pH plus pOH is always going to equal 14. Well, we just determined pOH is 2. What does pH have to be? Well, if we subtract 2 from both sides, we get pH is equal to 12. All right, so if we had taken that same 1 milliliter of base and added it to water, the pH would have gone from 7 all the way up to 12. Well, when we did it instead with our phosphate buffer, the pH went from 7 to all the way up to 7.19. So a much smaller change in pH. So this problem is designed to highlight for you the impact of having a buffer in solution, and the power of buffers basically to prevent changes in pH.